All right, finishing up number 17, we were solving for the F. We have 2,690 joules on the top, 23 meters times the cos of 32 on the bottom. And when you do this, you should get an F of 137.9 newtons, which should be how much force you need to push this shopping cart with. Number 18 is a farmer. And the farmer pushes a wheelbarrow with an applied force of 124 newtons. The farmer does 7,314 joules of work and pushing it a horizontal distance of 77 meters. Find the angle. So this time you're solving for theta. So W equals F delta D cos theta. So cos theta is going to equal W over F delta D. So W 7,314 joules over 124 newtons times 77 meters. And remember what you get here, that you get 0.766, etc. That's cos theta. Then you need to do second function cosine. And when you do, you should get 40 degrees. Okay? It's number 18. Then I asked you to flip over to do the work powers questions. And they are over on page 266. Sorry, the power questions, not work power. So number 41 says a mover pushes a 25.5 kilogram box with a force of 85 newtons down a 15-meter hallway. So F is 85 newtons. Delta D is 15 meters. And it takes him time 8.3 seconds to do this. And it wants to know find the power. So we know power is equal to work over time, and we know work is F delta D cos theta. So the F is 85 newtons. The delta D is 15 meters. Whoops, the delta T still on the bottom there. The angle will be 0 degrees because he's pushing it down the hallway and it's moving down the hallway. And the time is 8.3 seconds. So power should end up being 153.6 watts. That's 41. 42 says a chairlift carries skiers uphill to the top of a ski run. If the lift is able to do 1.85 times 10 to the 5th joules of work in 12 seconds, what is the power? So this one's really straightforward. It's just power is equal to work over time. 1.85 times 10 to the 5th joules, and the time was 12 seconds. And so you should get a power of 15,000, only I could make out my writing, 416, whoops, it really is a 1 and a 6 there, 0.7 watts. Okay, and then it wants to know what is it in horsepower. So to change to horsepower, we know that 1 horsepower is equal to 746 watts, and I think I told you that in the video the other day. Okay, and so if we have the watts, 15,416.7 watts, if we divide it by this 746 watts per horsepower, we'll find out how many horsepower, and it ends up being 20.66 horsepower. I don't think I have room for 43 on this one. Let's see what it is. A 75-kilogram student runs up 2 flights of stairs in order to reach her next class. The total height of the stairs is 5.75 meters from ground level. If the student can generate 200 watts of power and has 20 seconds to reach her class, will she be late? All right, so This is 43. So it says that her mass is 75 kilograms. And so the force she's going to have to generate is going to be having to equal to her weight, okay? It tells us the height, or in other words, the delta D, is 5.75 meters. And it says that she can generate 200 watts of power. Okay, so if we do power is equal to work over time, we want to see, will she be late? In other words, can she get there in 20 seconds or not? So let's rearrange this for time. Time is equal to work over power, and work is F delta D cos theta over power. So F is going to be 75 kilograms times 9.81 meters per second squared. And the delta D is the 5.75 meters. And again, it'll be cos of 0. And the power is 200 watts. And when you do this, you get a delta T of 21.15 seconds. So will she get there on time? No. She'll be 1.15 seconds. Like some of you, the bell rings and then you walk in. She'll be close, but she won't be on time.